So hello! Today I'm gonna do the topic of my video is thermodynamics. You probably don't know what that is. So the first law of thermodynamics states that energy can neither be created out of nothing nor can it be destroyed. Well, it literally means what it says. You can't make energy out of thin air and you can't destroy energy. You can just use it up though, as we'll get to in the second law of thermodynamics. Okay, so the first law of thermodynamics is also called law of the conservation of energy, but face it, like the first law of thermodynamics is a way better name than the law of the conservation of energy. The second of the law of the thermodynamics states as more and more energy is transferred, more and more energy is wasted. So if you have a battery and you have a wire connecting the battery to a light bulb, the battery will charge the wire with electricity, and as it goes to the light bulb to power the light bulb, the energy will have less and less power. So the energy that actually gets to the light bulb and lights it up is not the energy that started in the battery. Get it? Okay. Well, that was a short explanation. The third law of thermodynamics states as the temperature of the system gets closer to absolute zero, its entropy becomes more constant. Entropy is just entropy is just like see here. Entropy is just like it's not like it's not going to be exactly like the same between two systems, right? So you see here, that's entropy. It's unpredictability. Well, but if it gets closer to absolute zero, which is negative, let me see, negative 273.15 degrees Celsius. You can also represent it as 0 degrees Kelvin, which is easier. So let me explain this. So if you have two systems, like they're like gonna be at different temperatures, right? They can't be at the exact same temperature. But if you decrease like the room temperature to negative 273.15 degrees Celsius, the two systems will gradually, slowly get closer to the same temperature, which is absolute zero, negative 273.15 degrees Celsius. I don't know why I keep saying it. I should just say zero degrees Kelvin. Get it? Okay. The zeroth law of thermodynamics. I don't really understand this, but I'm getting that if like two systems are in thermodynamic equilibrium with the third system. Equilibrium means like the same, by the way. Third system, like the two original systems, are in thermal equilibrium with each other, which means they have the same temperature. Okay, so the two original systems are like like the two let me see here. These two systems are the original systems. The third system is not original. Like the two systems are in thermal equilibrium with each other, so they can be in thermodynamic equilibrium with a third system. At least that's what I get from this statement. Okay, so comment if you understand this. Actually, don't comment. I don't want to read your comments. It's kind of weird. Just judging me. Don't judge me. It's mean. You're all meanies. Meanie boffinis. By the way, also sub right now. I forgot to add this. Or else you may find your house be burned down. Okay? Sub right now or else.